Hello everyone, and welcome to tutorial sheet 1, and in this one we're going to specifically look at question 3. So we've moved on from units, and what we're going to do here is just look at force vectors, particularly trying to find the resultant. So as always, it's really important to look at the question that we're trying to do here. So what it asks for in this question is find the resultant force vector and the direction of this vector relative to the positive x-axis for the following set of forces. So what you'll see from that PDF are a variety of them, but we'll just look at part A. So what I'll do is we'll solve this using both the trigonometrical method as well as graphical. Now you may already have decided that I'm only ever going to do the trig method, and I want to pause you there and say that it's quite important to be able to do both methods, because when you move into 3D, trig becomes quite difficult. So it's really important to know both ways and be able to answer all of these questions both ways. So you'll notice here that we have a graph pad and a ruler here, but also I can change this to different degrees. So that's just showing that you can do this using your protractor and your own ruler. So first things first, we'll do the trig way, and I like to do things in steps. You can do it in whichever way you want, as long as you get the right answer and make sure you show your work. If you do it this way, you get most marks. So for me, the first step is always setting your axes. Alright, so what do I mean by that? So you can see here these axes here, x and y. This is technically incorrect, because what I want to know is what is the positive x and what is the positive y, because you'll see in the question, find the resultant force and direction relative to the positive x-axis. So typically I always say that this direction here is the positive x and this one here is positive y. So you don't have to do the other directions, because I can infer that this is negative x and I can infer this is negative y, so there's no need to do it. So as a rule of thumb, I really would get you to draw this so that I know that you know what you're talking about. So for the trig method, the second step then is dividing things up into the two directions. So what do I mean by two directions? The x and the y. So you'll see this is quite a relatively easy question, because the forces are not in odd directions. They're along the positive and negative x and positive y, positive negative y. So what we'll do is we'll just separate the forces in the directions in x and y. So I'll just use a different pen here so we can visualize that. So the forces, so F in the x direction, right? So we can call that F, we can call that R, it doesn't really matter. So we know, so this is the x direction here, we know that this 12 Newton is in the positive direction according to the axes that we set, so that's fine. This this 20 Newtons is in the minus x direction, so we know that's going to be a minus, right? So we have a positive 12 Newtons, we can put the units in. So we'll go plus, but we know that it's a negative, so we'll put it in the brackets, negative 20 Newtons. So when we get that, we realize that it's a minus 8 Newton force in the x direction. Great. So simple out. So next one then is the forces in the y, so we'll call them, because we started with F, we'll continue with F. So the forces in the y, so the subscript is y. So again, we'll start with the positive, so 15 Newtons is in the positive y direction as we set it. So we'll go positive 15 Newtons plus, now we know this is in the negative y, so this is going to be brackets, negative 10 Newtons. So that equals, so we have 15 minus 10, so we have a positive, we just put the positive sign there, positive 5 Newtons in the y. So this is our y direction, and here is our blue is in positive. Alright, so now that we know the components, so we only have a resultant now in the x, in its x and y, so we actually want to know the resultant force, because knowing it in its components isn't correct. So step 3 is to find resultant, which is the ultimate goal, but using Pythagoras. Right, so the Pythagoras equation, which I assume you will all know. So that's the case there is, I'm going to change these now to R just to make things so it's the resultant, but realistically it doesn't really matter. So Rx, Ry. So we want to find the resultant, right? We have its x and y components, so the resultant, and using Pythagoras, so r squares, we're going to say that it is r squared equals the x component. In this case it is, we can leave the minus in if you want, 8 squared plus the 5 squared. Alright, so what do we get here? So I'll just stay in the black color. So we get r squared equals, that turns to be 64, the negative goes, and that's 25, so 5 times 5. So that's your, that's those done. So now what we do need to do next is we need to put these into a square root. So if we bring the square over, we get the square root of this answer. So r then will equal 9.4 newtons. So that ends up being the square root of 89. Alright, so from this, it states that the magnitude of the resultant force. So what do I mean by resultant? So you might be thinking, what does this 9.4 newtons actually mean? So if we go back here, so if we were, so pretend this is a football, alright, and this football has 4 threads on it, right, 4 ropes tied to it, right, and they are these forces here. The resultant is that 9.4 newtons. So this ball is going to be pulled in a direction, and the magnitude of the force, right, it can only go in one direction, it can't spread out 4 ways, it's going to be 9.4 newtons. But here's the question, what's the direction? And that's why it's really important to have this direction, right, because we don't know where that 9.4 newtons, we just know that it's going to be a force vector that is 9.4 newtons. So we don't know that yet. So that's why we need to do the next step, which is find the angle. So step 4 is find direction. So how do we do that? Now you already have a rough, you can figure it out through a rough idea. So what I'm going to do here now is just get this ruler out here. I'm just going to do a quick axis. Make it green. Alright, and bear with me now. Okay, so we'll do the Y here. Okay, so push that over there. So as you can see, this will be our positive X, positive Y, negative X. Now this isn't, you're thinking, well, this is graphical. Well, this is just to represent to you what's going on. So you will remember that we already got the X and Y components earlier. So the minus 8 and the plus 5. So what does the minus 8 signify? Well, if we go back to blue here, that means that, let's pretend these are in 4s. So 4, 8. Alright, so this is 8 newtons because it is in the negative X direction. We know that the Y component is positive 5, so we know it's in this direction, and it's, let's say, somewhere here. So we know this is positive 5, so it's up this direction here. So we know, if we bring this across here and bring this up here, that roughly this is the direction of our resultant. So why am I showing you this? This is just to tell you that we know that it's in this direction, roughly. So it's in this this quadrant, this second quadrant, which we'll talk about in the lectures. So you know that the angle relative to the positive X axis is somewhere here. So we'll call this angle beta. Alright. So we know that this angle beta is what we're looking for here. So how do we do this? Let's say that this angle here is alpha. So what do we know about alpha and beta? So this is the step 4. So alpha plus beta, right, just variables for angles, equal 180 degrees. So a straight line is 180 degrees. So we have two variables, which is a problem. So we're ultimately looking for beta, but the easier one to find is alpha. And you were wondering why. Because it makes up a triangle. So if we pull this resultant out here, so let's say this is our resultant here that we know is 9.4. Right, we know already it's x or y component, which is 5, and we know it's x component, which is, oh, that did not work out, which is 8. So we have, we'll go back to our colors here, so we know that this vector, force vector here is 8 in the x, we know that this is 5 in the y, and we actually know our resultant is 9.4. So we know it's a right angle triangle, and we're looking for alpha. So how do we find alpha? So we just know from general trig that cos alpha is adjacent over hypotenuse. We can use any one of them. We can use sine, we can use tan. That's absolutely up to you because we have all three lengths. In this case, they're forces. So because length in this case equals a magnitude. So we only have the magnitude of our force vector. We do not have the direction. So what is adjacent? Adjacent is 8, right? Adjacent to the angle 8, and hypotenuse is 9.4. So we just do this, so alpha, so bring that cos over, makes it cos to the -1, and adjacent is our 8, hypotenuse is 9.4, right? So we get alpha equals cos of whatever this works out to be, which is, if I remember correctly, is approximately 31 degrees. So we'll just kind of round up, round down. So 31 degrees. So this is our direction. We're not there yet because remember, what did the question ask? Right, and this is where people fall down, is they just get that nice degrees and think, I'm done. Is that we have found the resultant, check. Direction, yes, but we haven't found it relative to the x-axis, and that's what beta is. Let's scroll down, and if you're wondering what I mean, because the question asked us for this angle, this direction relative to the positive x-axis. This alpha is actually positive to the negative x-axis. So if you gave me that 31 degrees, which is correct, it is 31 degrees from the negative x-axis, that's not correct. So we need to find a beta. So we already know this because we created this guy here, alpha plus beta equals 100 degrees. So we can, if we just go over here, beta equals 180 degrees, it says 0, supposedly, minus this 31 degrees. So beta equals 149 degrees. Now here's the key. I really want you to do this in the exam. Write down 149 degrees from the positive x-axis. So it says to me, when I'm looking quickly for the answer, I know that if you have this written down, that you've read the question correctly. When you say from the positive x-axis, it means that you understood the question and what you had to do, so that now you know that this resultant r, right, which is magnitude of 9.4, is 149 degrees from the positive x-axis. And that is pretty much it. Now you're probably wondering, well, what if I got 148? So if you actually go into the answer, it says 148. I don't mind, you know, because I rounded up and rounded down in parts, you're going to get probably 147 to 150 degrees. That doesn't matter because you're within that 5% range. Everything here is perfectly done, other than the fact that I rounded up quickly here. So don't worry right now. It's all about going through these steps and doing those steps right, because that's where most of the marks go. Just because you're 1 or 2 degrees out, at this stage in your engineering career, isn't going to be something that we're going to downgrade for. So this is the trigonometrical method of doing it, and a lot of people will be comfortable with that. But what a lot of you will be thinking, what does this 9.4 newtons truly mean? I mean, how did you get that, like, visually? And that's where the graphical method is really good, is because it allows and affords you to do that. So what I'm going to do here is I'm going to bring these, I'm going to bring this guy over, right? And I'm going to bring it here. So what we're going to do is we're going to make an axis, right? Like you would in your own graph paper. Give it a color that you can see. I'm going to try and line it up here as close as possible to a line. All right. So I'll just put it down quickly here. And what we're going to do here is, and this is, as I said, trying to match what you would do in reality as closely as possible, is try and draw this step by step like you would normally. And what's really good about the graphical method, not in this case anyway, is because the lines are nice and straight and it'd be easier to do it using trigonometrical methods. But when you have crazy angles, and this is where I talk about in 3D, this is where graphical method becomes quite important. So step one is actually the same as in trig. So step one is always set the axes, right? It's just a good thing to get yourself into. Now I'm just scribbling it here, but positive x is in this direction here, and positive y is in the vertical. All right, you can easily put them here as well if you wanted to. So let's move this ruler out of the way. So what do we want to do here? So remember from the lectures, you can take any one of these forces and start off with them, and start from the center. So So let's take we'll take 15 Newton as the first one. So we'll use red. All right. So if we're using 15 Newton, we know that it's going 90 degrees and in the vertical direction. So 90 degrees from the positive x-axis. So now you're wondering, well, how far do I go? So what we'll do is the next step is always set your scale. Set scale. Now, unfortunately, in this edition of Microsoft Whiteboard, I believe the ruler is in inches, which just doesn't help the cause here. But what we'll do is we shall say that, and if you can just about see it here, that from each one of these blocks is 4. So we'll say that each one of these is a Newton. So from here to here is a Newton. So 1, 2, 3, 4. All right. So we'll just line it up here. All right. So we want to go up 15 Newtons. So some blocks of 4. 4, 8, 12, 13, 14, 15. So right here. Okay, so we're going to draw a line. It's black, unfortunately, but we'll go with it. Alright, so that is our 15 Newtons. So you're wondering, I kind of went the wrong way. So you actually start here and you push all the way up here, and this is our 15 Newton here. So this is our 15 Newton load. So the next thing is we'll go with 12 Newtons. Now 12 Newtons is now fully horizontal. You can go with any other one, but just visually this is easier to go with. So again, we'll line it up here, try and get it right on the line, and you should do the same. So physically you should be doing the same thing. So get it right on that dot here. So we'll come across, so 4, 8, 9, oh sorry, and then 12 is here. Oh, crap. So there, that's 12 Newtons. So this is our 15 Newtons. This is our 12 Newtons. Just put a little arrow here. So it's going from here, so we're drawing this, the start of it, force vector, all the way to here. So next one that we'll do is 10. So again, the directions are easy, it's just 90 degrees. Okay, and we'll move it, try and get it right on here. So again, we'll line it up here. So each one of these blocks is 4. So 4, 8, 9, and 10. All right. So that is a 10 Newton one. can imagine you're much quicker on this, so you can speed forward on this video. Now the next one is the final one then, is the 20 newtons. So I'll just line this up here if we can. Again, blocks of 4. It just needs to move up a bit. Okay. So 4, 8, 12, 16, and 20. Alright, so that's all 4 vectors done, and we end up right here. So our resultant will be connection between here, right, the starting point of where we started with the 15 newtons and where we ended with this 20 newton force vector. Alright, and you can do them in any order, you'll end up with the same thing. Right, so what do we want to measure here, just to prove that it's the same as the trig method? So let us actually just bring this over here, and let's look at what value we get in the y. So what do we get in the y here? So let's look at it. So 4 and 8. So it says it's 8 newtons in the x, should I say. So in the x direction, the resultant in the x is 8 newtons. So you should recognize that from the trig method. This is the negative x, and that's why it is a negative 8. And if we flip this over, we should get 5 then. Alright. So it's measured from the line here. Alright, so 1, 2, 3, 4, 4.8. So it's not even, well, actually, if we pull this down a little bit, just below the 5 mark, which is not exactly what we got before. So we'll say 4.8. So this is what happens, is you can see there's a couple of errors here just from awkwardness of using this, but we'll go with it. So we'll say 4.8. And again, this is where, especially in graphical method, there's leniency. So 4.8. Now, here's the next thing. We now draw this line. So we see if you have to draw the resultant, these are just the components to show you they're the same. So remember we said that the alpha, so the alpha as in the degree from the minus x-axis is 31 degrees. So if I put 31 on this, let's see if it lines up. So 31. Let's zoom back in a bit here. So 31. Okay. Doesn't match up. Just about matches up there now. So maybe if we 30 is probably just a little bit better. You can see there's a little, again, discrepancy. So let's go with blue, and we'll just draw a line here. There you go. So let's look at the length. So 4, so let's try and get it again. So 1, 2, 3, 4, 5, 6. That makes no sense. Ah yes, because I zoomed in. That would do it. Let's see what way it was. I forgot that this doesn't work like that. Let's try and scale it back to what it was. It's about right, yeah, 8. Apologies. Go back to 31 there. Alright, so did 30, didn't we? Right, so 489.4. So we got our resultant correct. So just in case you missed that, we'll go back again, and again the alpha is a little bit off. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's the half mark, so just around 9.5, 9.4. So for correctness, we'll say that the resultant R equals 9.4 newtons. Alright, so and we've already got the angle here, so the alpha according to this is 30 degrees, but if we were to measure this with your protractor, you will find that beta in this case is 150 degrees. Alright, from, and don't forget, from the positive x-axis. So make sure to write down, and I see it, that R equals 9.4 newtons, or 9.5. You can see that there's a bit of discrepancy, and I allow for that. And that the angle, theta we'll call it, but or beta, it doesn't matter, is 150 degrees from the positive x-axis. So hopefully this gives you an idea of the two methods that you can go about it. Yes, you can argue that the graphical method takes a lot longer, but it gives you a real appreciation and visualization of how this and where this 9.4 comes from. And if that's something that you get, then that's totally fine. But when the angles become a little bit more difficult, and when the angles are in 3D, that's when things get a little bit more interesting. So that's why I really push for you to understand the graphical method. What's key here as well is when you're giving me the answer, make sure that the answer has the number and the correct SI unit. Don't give me kilonewtons. And that the angle always is saying from the positive x-axis. And it's just a good habit to get into. And that goes for both the in trigonometrical method versus the graphical. So you can see the resultant and the angle are pretty much the same. Thank you very much.